Good morning, students. Today we will discuss NCERT solutions, Maths class 11th. In this, I will explain you how to solve the questions of limits and derivatives. So I will explain solutions of all the questions given in NCERT books. You see, while calculating the limits, you have to take care of the few points. So first you note down all those points. First one, there may be question to check whether a limit exists or not. A limit exists or not. To check that, we'll calculate left hand limit. That I will explain later on how to calculate it. We'll calculate right hand limit. If the value of left hand limit becomes equal to value of right hand limit, then we can say limit exists. It means limit exists. If it is not equal, if left hand limit is not equal to right hand limit, then limit doesn't exist. Second thing which you have to take care while calculating the limits, there may be questions you calculate this limit. There are two type of question. Check the existence of limit, then you have to calculate left hand limit, right hand limit. If both are equal, limit exists. Second one, there may be question directly to calculate a limit. So calculating a limit means you have to put, suppose limit x tends to 1 is given and a function is given. So you have to put x equal to 1 in the function. That's all. But if you are getting 0 by 0 form, basically in class 11th NCERT 0 by 0 form is there, or 1 by 0 form. 0 by 0 form means on replacing x, y, that a, if you are getting numerator as 0 and denominator as 0, or you are getting numerator as 1 or denominator equal to 0, then we will not replace. We will further solve that one particular question. So our objective is to solve the limits is simply remove 0 by 0 form or 1 by 0 form, whatever is given. There are many forms, but I am explaining the questions of NCERT class 11th only. So in 11 there are only two forms, 0 by 0 or 1 by 0. So we'll try to solve it so that we can remove the 0 by 0 form. So you just see the questions starting question 1. Limit x tends to 3, x plus 3. Simply replace x by 3 in this. You get 6. So 6 is the answer. Question number 2, it is given limit x tends to pi, x minus 22 by 7. So replace x by pi. So it will be pi minus 22 by 7. You know that 22 by pi is also 22 by 7. So its answer is 0. Question number 3, limit r tends to 1, pi r square. Just replace r by 1. You will get answer is pi. Question number 4, you see, it is limit x tends to 4x plus 3 upon x minus 2. In this you replace x by 4. So you get 19 by 2. So this is the answer. In case you get 0 by 0, we have to further solve it. That question I will explain later on in the same exercise. Similarly, question number 5, it is given limit x tends to minus 1. So numerator and denominator, wherever x is there, you replace that by minus 1. So finally you will get minus half as the answer. Now you come to the question number 6. It is given limit x tends to 0. Now you see this is 0 by 0 form. This question is 0 by 0 form. If I replace directly limit x equal to 0 in this, so numerator will be 1 minus 1, that is 0, and denominator is also 0. So now you have to further simplify it. You can't put limit directly in this question. So to simplify this question, okay, note it carefully. We'll replace x plus 1 by y. We'll replace x plus 1 by y. As we are replacing x plus 1 by y, as the limit x tends to 0 is given, we have to convert all the terms or this whole question in terms of y. So we have replaced x plus 1 is equal to y. So limit is given x tends to 0. So you put in this x equal to 0 to get the limit of y. As x tends to 0 is given, so in this you put x equal to 0. So it will become 0 plus 1 tends to y. So the new limit will be y tends to 1. New limit will be y tends to 1. Your previous question, the question was given in terms of x. Now we'll convert this whole question in terms of y. So what I have done, I have replaced x plus 1 as y. As x tends to 0 is given, so in this I will put this x equal to 0. So 0 plus 1 tends to y. So new limit will be y tends to 1. So now new limit is y tends to 1. And your x plus 1 is equal to, we have replaced it by y. So now the question is reduced to, this will be y raised to power 5 minus 1, limit y tends to 1. In denominator you have to put this x. So get the value of x from here, it will be y minus 1. So the question is modified as limit y tends to 1, y raised to power 5 minus 1 divided by y minus 1. Now there is a theorem. What is this theorem? You just see, theorem is x raised to power n minus a raised to power n divided by x minus a is equal to n into a raised to power n minus 1. Now how to identify this theorem? In this, see, limit x tends to a is given. First thing, in denominator the difference of these two terms x minus a, in numerator is also it is x minus a, but equal powers on x and a are given. Suppose power on x is 5, so power on a should be 5. So answer of this limit will be n, means the power on x and a in numerator, that is n. This term is a, n into a raised to power n minus 1 would be the answer. Just to explain the same thing, suppose it is given x7 minus 27 divided by x minus 2 is given in any question. If it is given limit x tends to 2, you see it is the same form. Because it is x tends to 2, so denominator is x minus 2, numerator is x minus 2 again. But some equal power is given in both x and 2. So it is x raised to power 7 minus 2 raised to power 7. So to write the answer of this, what is n? This power is called n. So it is n into, what is a? It is 2. Raised to power n minus 1. This would be the answer. So in our question, now I have to solve it. Limit y tends to 1, y raised to power 5 minus 1. So I can write it as limit y tends to 1, y raised to power 5 minus 1 raised to power 5 divided by y minus 1. So you see n is 5 and a is 1. Okay, n is 5 and a is 1. So on comparing with this, your answer will be n into a raised to power n minus 1. So n is 5, a is 1. So 1 raised to power 4. 1 raised to power anything is 1 only. So answer of this question is 5. Come to the question number 7. It is 3x square minus x minus 10 divided by x square minus 4. You put x equal to 2 in this, because limit x tends to 2 is given. So you put x equal to 2 in this. On replacing x by 2 in numerator, you will get 0. You can check it. And denominator also you will get 0. See, it will be 3 into 4. That is 12 minus 2 minus 10. So numerator is 0. And denominator is x square minus 4. That is also equal to 0. So this is 0 by 0 form. So whenever we get 0 by 0 form, you can't replace it by x equal to 2. Now what to do? You factorize numerator and denominator. That is also one of the method. To remove 0 by 0 form, you factorize numerator and denominator. Factorize the numerator by splitting the middle term, and denominator is x square minus 4. That can be written as x minus 2 into x plus 2. Now what will happen? X minus 2 is a common factor in numerator and denominator. You just cancel out both. You are left with this. Now 0 by 0 form is removed. Now just replace x by 2. As soon as 0 by 0 form is removed, put x equal to 2. So it will be 11 by 4 is the answer. I have replaced x by 2 in this. Come to the question number 8. It is x raised to power 4 minus 81 divided by 2x square minus 5x minus 3. You put x equal to 3 because limit is given x tends to 3. So put x equal to 3. So on replacing x equal to 3, your numerator will be 0 and denominator is also 0. You just put the value and calculate. You will get it is 0 by 0 form. So whenever 0 by 0 form, you have to further simplify it. Okay, the limit is not x equal to 2. This is actually 3. There is a misprint. This is x equal to 3. So factorize x raised to power 4 minus 81. That will first come x square plus 9 into x square minus 9 using a square minus b square. X square plus 9 into x square minus 9. So x square plus 9 will remain as it is. X square minus 9 is further factorized as x minus 3 into x plus 3. Denominator, you just factorize it by splitting the middle term. So you will get denominator as x minus 3 into 2x plus 1. Now you see x minus 3 is a common factor in numerator and denominator. X minus 3 is a common factor in numerator and denominator. You just cancelled it out. Now you are left with this much particular part. In this you put x equal to 3. Okay, on replacing x equal to 3, you will get the desired answer. Question number 9. Limit x tends to 0, ax plus b upon c x plus 1. In this you replace x by 0. So directly we'll get b as the answer. You will always get direct answer. Only the cases in which it is 0 by 0 form, you have to further simplify it. Question number 10. Question number 10, you can just check it. It is again 0 by 0 form. You will replace z by 0, 1. So numerator is 0 and denominator is 0. So we have to further simplify it. Now how to simplify it? In this you just put z raised to power 1 by 6 as x. This z raised to power 1 by 6 as x. As limit z tends to 1 is given, so x is also 1. In this we put z equal to 1. So x is also 1 raised to power 1 by 6, so that is also equal to 1. Okay, as limit z tends to 1 is given, I will convert this whole question in terms of x now. I have replaced z raised to power 1 by 6 as x. As z is given 1, so x will be also 1. So your new limit will be x tends to 1. Now the question is reduced as it is x raised to power 1 by 3. As I have taken z raised to power 1 by 6 as x, so z raised to power 1 by 3 will be x square. So it is x square minus 1 upon x minus 1. You can factorize it or you can apply the theorem. So I will do it by factorization or by applying theorem also. On factorization, you see it will be x minus 1 into x plus 1. In denominator also x minus 1 is there. So we can cancel out it. It is limit x tends to 1, x plus 1 is there. So 2 would be the answer. In this you put x equal to 1. Or you can apply that the theorem. It is x raised to power n minus a raised to power n divided by x minus a. X square minus 1 square divided by x minus 1. So n is 2 and a is 1. You compare with this one theorem. On comparing n is 2 and a is 1. So in this way we can solve this theorem also. Question number 11 is given. So in 11 nothing is there, you directly put x equal to 1. You are not getting 0 by 0 form. So on putting x equal to 1, numerator is a plus b plus c and denominator is also a plus b plus c. Both cancel out each other. So it is 1 is the answer. Question number 12. Limit x tends to 2, 1 upon x plus 1 by 2 upon x plus 2. It is limit x tends to minus 2. X tends to minus 2. So again, this is 0 by 0 form. If we replace x by -2, so numerator is 0 and denominator is 0. So to solve this question, just take 2x as LCM in numerator. So it will be 2 plus x upon 2x. This 2 plus x will be cancelled out by this 2 plus x. So it will remain only 1 upon 2x. Now you put x equal to -2. So -1 by 4 will be the answer. While solving the limits of sine, cos and tan. So while solving the limit of sine, you have to learn this theorem. Limit x tends to 0, sine x divided by x is 1. Limit x tends to 0, sine x divided by x is equal to 1. In this, what are the essential things you have to check? The limit x tends to 0 means this thing should be tends to 0. Okay, and whatever is there in this theta, the same thing should be there in the denominator also. Suppose it is given limit x tends to 0. In numerator it is given sine x by 2. So in denominator also you must have x by 2, then only it will be equal to 1. Your this theta and this number should be same. Whatever is given with sine, in place of theta, same thing should be there in its denominator. Suppose in theta it is given 3x by 2, in denominator you must have 3x by 2, then only it will be equal to 1. That you have to take care of this thing. Okay, so I modify this formula in the some other form also. It is limit x tends to 0, sine x by x is 1, and you can also learn it limit x tends to 0, it is tends to 0, sine ax by ax is also 1. So this is the second form of the same theorem. Means whatever is given over here, the same thing should be there in the denominator. Means in place of a you can have any number. It is 1 by 2, 3 by 2, 5 by 2. So if it is sine 5 by 2x, in denominator you must have 5 by 2x. Denominator you must have 5 by 2x. So using this theorem we will solve the questions. Like question number 13 is there. It is limit x tends to 0, sine ax by bx. You put x equal to 0, this is 0 by 0 form, so we can't put limit directly. So what to do, as I have just explained, sine ax by, it is given sine ax. So even denominator of this ax is there, then we can put it as it equal to 1. Okay, as I have just explained that sine ax upon ax is 1. So what I will do, you multiply this by ax in denominator and ax in numerator. This bx is already there in the question. So this ax by bx, x is cancelled out. We'll have a by b only. The a by b, in this a by b term there is no x, you can take it outside. A by b term there is no x, you can take it outside. Now as x tends to 0, your ax will be also tends to 0. As I explained, this theta should be tends to 0. So it is sine ax upon ax is 1, that I have just explained. So limit x tends to 0, sine ax divided by ax is 1. It will a by b will be the answer of this question. In this it is given sine ax upon sine bx. So you put x tends to 0, so it is again 0 by 0 form. So what we do actually, we'll apply the same theorem in numerator and denominator separately. So to apply the same theorem in numerator, I have divided sine ax by ax and I have multiplied this by ax also. Divided and multiplied. Similarly, I have divided by sine bx by bx and multiplied also by bx. So it is sine ax upon ax into ax divided by sine bx upon bx into bx. Okay, so to apply the theorem, now you see the sine ax upon ax directly we can put it is equal to 1, because as x tends to 0, so ax is also tends to 0. X tends to 0, bx is also tends to 0. So this thing is 1. Also this thing is also 1. Now you cancel out this x by x. We can take this a by b outside. Now limit x tends to 0, sine ax upon ax is 1. In denominator we can apply limit x tends to 0, sine bx upon bx is also equal to 1. So A by B would be the answer of this question. Come to the question number 15. It is sin pi minus x upon pi into pi minus x. In this, limit is given x tends to pi. Limit is given x tends to pi. So in this question, what we'll do, as limit is given x tends to pi, so pi minus x tends to 0. Sure, this thing is tends to 0. You have to check while applying the formula. Limit x tends to 0, sine of whatever is there at this point, the same thing should be there in denominator. This is the first condition. Second condition is this thing should be tends to 0. That you have to check. Means when x is 0, this thing, if this thing is also 0, whatever is there, and same thing is there in denominator, it will become 1. Okay, it will become 1. Limit x tends to 0. Suppose here 5x is given. Over here 5x is given. So what will you do? You will check whether 5x tends to 0 or not. Yes, it tends to 0, and same thing is there in denominator. We replace it by 1. So in this way we can get it is equal to 1. So like it is given sin pi minus x upon pi into pi minus x. Limit x tends to 0. This is 0 by 0 form. So in this question what I will do, I will take out this pi outside. Now it is limit x tends to pi sin pi minus x upon pi minus x. You see as x tends to pi, so pi minus x tends to 0, that I have mentioned over here. Now this thing tends to 0. So as per this property, this will become 1. And same thing is there in denominator also. So this is equal to 1 only. So 1 by pi we will have the answer. Okay, 1 by pi we will have the answer, because pi minus x tends to 0. Sin pi minus x upon pi minus x is 1 only. Question number 16. Directly you put x equal to 0. This is not 0 by 0 form. If it is not 0 by 0 form, you can directly have the answer. Put x equal to 0. So it is cos 0 upon pi minus 0. That is 1 upon pi is the answer. Question number 17. In this you put if x equal to 0, cos 0 is 1. So it is 1 minus 1 upon 1 minus 1. So it is 0 by 0 form. So many methods are there to solve it. It is done by one method. I will explain it by another method. You see how. You put cos 2x is equal to 2 cos square x minus 1. Cos 2x is equal to, you put 2 cos square x minus 1. 1 minus 1 is already there. Numerator I am solving. I have replaced cos 2x by 2 cos square x minus 1. So now it is 2 cos square x minus 2. Numerator 2 you can take common. It is cos x cos square x minus 1. You factorize the numerator. It is 2 cos x minus 1 into cos x plus 1. Denominator already cos x plus 1 is there. Now I am putting denominator. Okay, so this is cancelled out. Sorry, it is cos x minus 1. So this is cancelled out. You will have 2 into cos x plus 1. So I have simplified whatever is given. It is 2 into cos x plus 1. Okay, I have simplified using the trigonometry. Now we will put limit x tends to 0 in this. So you put x equal to 0 in this. It will be 2 into cos 0 plus 1. Cos 0 plus 1. Cos 0 is 1 only. So 1 plus 1, it is 2. 1 plus 1, it is 2 into 2. That is 4 would be the answer. So what I have done, I have replaced the numerator is cos 2x, and the formula for cos 2x is 2 cos square x minus 1. And 1 minus 1 is already there. I have simplified it. So your numerator comes out to be 2 cos x minus 1 into cos x plus 1. Denominator is already there, cos x plus cos x minus 1. So both will cancel out each other. Finally, you have only, it is equal to 2 into cos x plus 1. So you can simplify it. This is a very important question also. So take care of this while solving it. So I have explained this with the easiest possible way. In this PDF, it is explained by some other method. So you can also try by that method. Now come to the question number 18. 18 is, it is ax plus x cos x upon b sin x. Put x equal to 0, it is 0 by 0 form. In numerator you will get 0 and denominator also you will get 0. Put x equal to 0, this is 0, this term is 0 and sin 0 is 0, so it is 0 by 0 form. The b has nothing to do with the x, so I have taken this b outside, and numerator I have taken x as common. You see it is common. So in numerator you have, it is a plus cos x upon sin x. Now limit x tends to 0, we can write x upon sin x separately into limit x tends to 0 a plus cos x. It can be written as 1 upon limit x tends to 0 sin x by x, limit x tends to 0 a plus cos x. Now we know that this thing is 1, and in this you put x equal to 0, so it will be a plus cos 0. We have written this as 1. This is a plus cos 0 and cos 0 is actually 1. So it is 1 upon b, a plus 1 is the answer. Question number 19 is limit x tends to 0 x sec x, that is limit x tends to 0 x upon cos x. This is not 0 by 0 form. So it is only 0 is the answer of this question. Question number 20, it is sin ax plus bx divided by ax plus sin bx. You just see it is 0 by 0 form. You put x equal to 0, so sin 0 is 0, in this x is there, so this is 0, this is 0 and this is also equal to 0. So it is 0 by 0 form. In this question, what will you do? Again, we'll use the same property. As x tends to 0, ax tends to 0, and x tends to 0 means bx is also tends to 0. So to make this as 1, we know that sin ax upon ax will be 1. So I multiplied it by ax and divided also by ax. Similarly, in denominator, I multiplied sin bx by bx and divided this also by bx. Now I have written it as limit x tends to 0 sin ax upon ax into limit x tends to 0 ax plus limit x tends to 0 bx. In denominator also it is limit x tends to 0 ax, limit x tends to 0 bx plus limit x tends to 0 sin bx divided by bx. Now this is 1, this is also 1. So put both these two equal to 1. On replacing this by 1 and this by 1, you will have limit x tends to 0 ax plus limit x tends to 0 bx divided by limit x tends to 0 ax plus limit x tends to 0 bx. So numerator and denominator are equal, so both will cancel out each other, so your answer is 1. Come to the question number 21. It is limit x tends to 0 cosec x minus cot x. It is infinity minus infinity, both are infinity actually, means 1 by 0 is also not acceptable. Infinity means 1 by 0. Only two forms are not acceptable in which you get the answer 0 by 0 or 1 by 0 are not acceptable. In this we are getting 1 by 0. So to solve this, what we will do? You just convert cosec x as 1 upon cos x and cot x as cos x upon sin x. So it will be 1 minus cos x upon sin x. So in denominator, to make it as 1, I have multiplied it by x in numerator, divide numerator by x, also denominator by x. Now we know that sin x by x is equal to 1. Sin x upon x is equal to 1. And there is a theorem that limit x tends to 0, 1 minus cos x divided by x is 0. This theorem is there in your NCERT, so you can directly use it as a theorem. So limit x tends to 0, 1 minus cos x divided by x, you can replace this by 0, and limit x tends to 0, sin x upon x is actually 1. So it is 0 by 1, so answer is 0. The next question is limit x tends to pi by 2, tan 2x divided by x minus pi by 2. Tan 2x divided by x minus pi by 2. So I will solve this question. You see, it is x tends to pi by 2 is limit is given. If you put x equal to pi by 2, it is 0 by 0 form, because it will become tan pi upon 0. If I replace x by pi by 2, it is tan pi upon 0, that is 0 by 0 form. So in this question, what we will do, we will replace x minus pi by 2 by y. We will replace x minus pi by 2 by y, and I will convert whole question in terms of y now. X minus pi by 2 you replace by y, as x tends to pi by 2 is given. So x minus pi by 2 will become 0. X minus pi by 2 tends to 0. And we have taken x minus pi by 2 as 0. So your new limit will be y tends to 0. So we'll modify it accordingly. Your new limit in place of x tends to pi by 2, it will be y tends to 0. We have replaced x by pi by 2 plus y. In this question, we replace x by pi by 2 plus y. So in numerator, it will be tan of 2 into pi by 2 plus y, and denominator we have taken it as y. You just multiply it, it will be tan pi plus 2y. Now tan pi plus theta is tan theta, so it will be tan 2y. That can be written as sin 2y upon cos 2y. Now we can write it as sin 2y. To make it as 1, you know that there should be 2y in the denominator. As y tends to 0, so 2y will be tends to 0. So it will be sin 2y upon 2y. I have multiplied it by 2 in denominator and 2 in numerator. Multiplied by 2 in denominator and 2 in numerator. 2 in numerator and 2 in denominator I have multiplied. So this sin 2y upon 2y would become 1. And you are left with 2 upon cos 2y. In this you put y equal to 0. So this will be 2 upon cos 0. Cos 0 is 1. So its answer is 2. Okay, so I've covered till question number 22. In these we are calculating limits. After 22 there are questions in which we will check whether limit exists or not. Means we will calculate left hand limit and right hand limit. So that I will explain in the next class. So I hope you will be able to solve all these questions easily. Thank you.